Hey folks, welcome to Snowpal Software Development and Architecture Podcast. This is podcast number 4 in the Confluent Cloud series. In the previous one, if you haven't watched the other ones, I highly recommend you do so in order. That way you get context to this podcast. In the previous ones, we did a number of things like creating, topics, learning the basics of the Confluent Cloud system, and creating a Go client to publish messages, to consume messages, and a few other related items. Right? Definitely check out those 3 podcasts. In this one, we'll pick up from where we left off. We talked a little bit about connectors in the last podcast, but I just wanted to do one more podcast where we focused pretty much exclusively on connectors, because the ones we just touched upon connectors and used a connector, if I'm not wrong, in the previous podcast, but we didn't spend a whole lot of time talking about Confluent Cloud connectors, which is, as I understand it, that's where the value add comes into play, right? When you're using managed Kafka as a service, there's more than one option that's available. Why would you want to go with Confluent Cloud if you end up choosing to go with Confluent Cloud? Just as an example, we obviously have nothing to do with Confluent Cloud. I'm just sharing my learnings of different technologies along the way in these podcasts, in addition to sharing our learnings and products and services that we actually have at Snowpal as a company. Okay, without further ado, let me do a screen share here. Okay. Okay, my screen is being shared. So let's go to connectors. So here, if you notice that there is I added one connector. Now, we did this, I think, in the second podcast or maybe in the first one. I don't recall. This is a sample connector. If I recall this, it's one of those. They have a number of connectors, and we're going to take a look at some of them. I know how hands-on we might get in this particular podcast. We'll see. We'll play it by ear. But at least the first connector is the data gen source connector. I added this. It was just a bunch of clicks. We can even delete this, and you know what? Maybe it wouldn't hurt to just add it. Actually, delete the connector. Okay. Yep, that's what I thought. So they have like 221 connectors. Let's start with the simplest one, the sample data connector. It says it's used to generate mock data for development and testing. So that's what we're going to do. We're going to go here. We're going to have that published to the same topic we've kind of been relying on. One of the topics we created, I guess, was it from the command line or on Postman? Okay, in the previous podcast. I'm just going to say use one of these existing service accounts, add all the required ACLs, selecting a template. This is just generating sample data. So I guess we'll just pick orders, and JSON is the format. Now they have a few different formats here. Protobuf is the protocol buffer. I think I alluded to that in one of the previous podcasts, and probably do an exclusive podcast on protobufs and why they're optimal and the most efficient, probably one of the most efficient ways to do data exchanges. So you could pick that or pick JSON or Avro. What is Avro? Data exchange. Avro is an open source project that provides data serialization and data exchange services for Apache Hadoop. All right, okay. I've done a little bit of Hadoop, but that was a long time ago. So the binary format is more compact and efficient. That's also binary, which means what is the difference between that and Protobuf? If performance is a concern, Protobuf speed and efficiency make it a better choice. We need more complex data structures, and Avro may be better. This is a tiny bit of a distraction, but I want to look at an Avro example. Maybe we can, let's see. Learn more. This looks very Protobuf-y like. Yeah, I have not provide similar functionality to systems such as Protobuf. differs from these systems in the following fundamental aspects. Dynamic typing does not require that code be generated. Okay, untagged data. Since the schema is present and the data is read, considerably less type information need to be encoded. No manual. So there are some finer differences. I think this one seems like more than a fine difference. It does not require the code be generated. So it is similar in other ways to the notion of protobufs, the protocol buffers. We will take a look at this one. I've used this in the context of Golang in particular. So we look at that, in a different format. And then the third one is JSON SR. Let's go here. I've not used JSON SR. The latter offers integration with schema registry, registering and retrieving JSON schemas, while the former one does not. Let's see. Oh, no, actually, now that we have 4 formats, JSON, let's look at a quick example. Oh, hang on. Is JSON SR just JSON schema? Oh, yeah, that, okay. Most popular JSON schema is a vocabulary that enables JSON data consistency, validity, and so on. So I've used JSON schemas. I just didn't, I guess if that's the same thing, then I didn't realize it's called JSON SR. So we have the what is JSON SR? Oops. Just spend another 2 minutes. Let's see. JSON. Let's go back here. With and without schema registration. Yeah, I guess JSON SR schema registry required, yes, and schema inference, yes. So I presume if it needs to be strongly typed, okay, that's probably what the difference is. I'm just looking for a simple. SQL DB handles JSON and JSON SR formats differently. While the JSON format is capable of reading the schema from the registry, JSON SR both reads and registers new schemas as necessary. Okay. Yeah, I'm trying to think if I've actually clearly I've used JSON schemas, not JSON SR. I just want to make sure it doesn't look like it's the same thing. JSON SR just requires that you have, it has a schema requirements, the schema be defined, etc. But I don't think it's the same thing. Shouldn't there be a simpler place where we can? I don't think this is what I've used, the JSON schema, but this is probably not JSON SR. I don't think so. It just requires that, we saw those differences. Let's go with that. Supported formats, Avro, Protobuf, and JSON schema. Yeah, I think we could just go with that assumption. I don't know, it just has one for JSON here. Okay, I'm going to close this, close a bunch of windows. Okay, let's go back here. If I'm inclined to pick the one I actually not use quite a bit. I'm very familiar with JSON and Protobuf. Not so much with JSON SR, and certainly I've not used, I at least don't recall using Avro. So let's just pick JSON here, the simplest one, and we can even try the other one. I'm just going to pick the defaults. Topics, okay, I'm just going to hit continue. I believe we have a consumer running, so we'll see. Takes a minute or two for the connector to be provisioned. Yep, there you see it flowing through. We have these, if you remember, we have actually multiple consumers. We talked about this in some detail in the last podcast, number 3. So we have, let me make sure I'm actually recording. Yep, I am. Okay, so go back here. Yep, so we see these messages come through. This is just mock data. This is sent to this topic by this connector, right? Now I can actually pause the connector. So you'll see that messages stop flowing here. Can I change? Okay, let's change this to, I don't know, JSON SR. I'm going to click save. Okay, I'm going to hit resume. Don't expect to see anything particularly different here, but we'll find out in a second whether this the mock data is looking any different. Still starting up. Okay, there we go. Is there any difference? No, the only thing I see is the double question mark. Hang on. Wait, hang on. Actually, ordered ID, time, address, city, state, and zip code. Yep, there isn't any difference. I didn't expect to see any. So let's just pause here. Like I mentioned a few minutes ago, I think the fact that we're changing JSON to JSON SR shouldn't actually change the way this data is particularly flowing through. Okay, let's actually change it now to, well, where was it? Yep. Let's change it to Avro and see what happens. I'm gonna resume. Okay. So our consumer here, we have a Golang consumer. It's actually what is it? Reading the message. With some, let's go back here to the consumer. Yep, it reads the message and it's printing the key and the value. What does it return here? Returns a message, returning a byte array. So we change the format. Probably we'll have to make some code changes to handle this because the format is Avro, but nothing else was changed. But we don't see anything happen here, right? So it's surely consuming it, but our code is not able to. We need to write the code to handle this Avro format. I reckon that's what's happening here. Let's actually go to topics. Let's look at topic B. Messages. First of all, is it coming through here? These were the previous ones, I'm pretty sure. So I don't believe, let's see if the message count is even increasing here. I think it did, 13,195. Maybe not. Yep, I don't think. Let's see, let's do one thing. I'm curious now. Let's go back to the cluster connector. Yep, you see that it says it failed. Schema being is incompatible with the earlier schema, blah, blah, blah. Let's see if we recreated this. Is it going to make any difference? Okay, let's go with that. Let's go pick topic B. Let's do the rituals. Orders, continue. Continue. Okay, it's provisioning it. The connector is now running. Avro orders. Let's go to topics, podcast B. Still 13,195. Yep, there's nothing here. And it failed. It says schema being registered is incompatible with an earlier schema. The connector only supports topic name strategy. And if you need a different quick start, please change. Oh, please change topic name as well. Let's try that actually. Let's say we go here. I don't know. I'm going to add a new topic. Topic 9. Say edit this. Go pick this newest topic. Apply the changes. The topic underscore 9. So let's recompile this code. Do I need to? I've seen this after it fails. Is there a way to? Oh wait, hang on. Missing write permission on topic. You know what? Let's actually delete it and add it back again. Because I don't think we granted any explicit permissions on at the topic level at least. Okay, let's go here. Pick Avro. Let it complete. Apologies, a couple of these podcasts, okay, have been quiet for the most part. Okay, so here we see, so it's consuming it and it's binary, so we actually don't see it be posted here, right? So all that we have to do is we change the format and now we are actually receiving it in a slightly different format. Now, if you're using, doing data exchange of any kind, if you have the ability to do it using the binary formats, I highly recommend you do so. There's going to be an insane performance difference, and looks like between Avro and Protobuf, based on what we just read, Protobuf seems to be the faster one. And I've used that, and I think there's no question about it. If you can use it in lieu of using JSON. So, okay, so we are able to read off of that. I'm just going to go back here and recompile this, just so, because a lot of what we've been doing earlier, it's related to that. Okay, so we've seen that it was able to, I'm going to pause this because it actually costs more connectors you run, you pay by use essentially. So we saw a couple of different formats at least, and one, mock data generation connector. So let's go look at some other connectors here. Okay, let's go to all connectors. We saw there's like 221 connectors in totality. Let's go with some, let's say I was going to go with, first look up Mongo. So there's one for MongoDB Atlas and one for, it says MongoDB Atlas source and sync. What is the difference? And the idea behind, the main value add you get by using something like Confluent is, rather than using a straight up, Kafka implementation, is that you have access to these connectors, and then the hope is, and the reality is also that you're going to have to write a lot lesser code, and only code you don't want to write code that you don't have to write. As simple as I've said that many times, which is why, as a company, we provide these SaaS products and APIs to do all of the back end heavy lifting for you, which is why you shouldn't have to stand up, maintain, manage back end systems if you don't have to. Either you have no backend systems at all and you use this in entirety, or you have some and you can use our APIs to supplement and add more value to what you might already have. Similarly, we preach what we practice, so we do not reinvent the wheel ever. In that context, whether you're using Kafka, manage Kafka as a service, or you're using API gateways, if you have systems that provide connectors and the plugins and extensions and whatever each of them end up calling it, you certainly want to use them because you shouldn't have to implement what you don't have to. Okay, what is the difference between Atlas source and the other one? Let's see. Sometimes I think the documentation is sometimes only on the main page. The Kafka Connect MongoDB Atlas source connector for Confluent Cloud moves data from a MongoDB replica set into an Apache Kafka cluster. Okay, what is this one? Atlas Sync connector for Confluent maps and processes events from Kafka topics directly to a MongoDB Atlas. Process events from topics to a collection from a replica into a Kafka cluster. I'm wondering whether it's the direction. In other words, the Atlas source moves data from your MongoDB instances into something gets written to a MongoDB collection, a new document or a document's updated. A message gets generated and it's posted to a Kafka cluster that's running on Confluent Cloud. I wonder if you need the Atlas source for that, because it pulls it from Mongo, and this Atlas sync is basically taking a topic and then writing it to a Mongo DB, right? I would have thought the connectors were bidirectional, but maybe this means that it's not bidirectional. Yeah, moves data from a Mongo replica set into a Kafka cluster. That's one of it. Okay, and then this one, process events from topics directly to a database collection. That's what it reads to me. Maybe there's not a single connector that's bidirectional. Maybe there are two different connectors. At least that's what I would go with. Try it out and see how it goes. And to do that, let's say we did something like this. Let's see let's spend a minute or two to see what it entails. I reckon it's going to be pretty straightforward. Maybe it's a little bit slower than it should be, but okay. Topic prefix, it says will publish to topics using the prefix provided. So you could, whatever, right? Your prefix could be dev environment or whatnot, right? You add some sort of a prefix and then you continue. Again, you have the access that you grant. You probably want to create a different service account, and you can look through the ACLs. I'm just picking the defaults here. Okay, why is this so slow? Okay, and then you're going to have to put a key in the host, the username, password, the database name, and if it's one collection, I guess you can put single collection to watch. If not, set all collections are watched, right? So you can be granular if you only want a specific collection to be watched, because you probably would do that because you don't want all your collections necessarily to be watched. Maybe not. And then you click continue and you should be good to go, right? For setting this up. So it seems like it's pretty straightforward. That's for the source. And then I reckon it's going to be very similar in this direction. Yep, you pick a topic. So you want to pick a topic that you want to get data from, and then we click continue. You again grant this access, blah, blah, blah. And the next screen should probably shows the Mongo stuff, right? Exactly as we expected. So by virtue of doing this, we make, we're able to write data messages from a topic to your Mongo database, and then vice versa, right? You're able to pick data that was written to Mongo, and then you read it here. Now the question is, what kind of events do you want for it to act upon? Like when it says the source, I wonder if you can actually choose to act on certain events but not others. Like what if I'm interested in deletes but not like write a new, not like a create or an update, or maybe I'm only interested in an update and not anything else. I don't know if you can go to that level of granularity. I'm not sure. I'm not, looking at this here, it does not look like it. So any change probably is going to be propagated, and maybe you have to, maintain the logic to the extent you need to on the consumption side, on the side of the consumer that is going to react to these messages, listening to those destinations or topics. Because I don't see any events, but maybe there is, but I would go with there isn't one because I'm not seeing any there. Those are two, right? So out of 221 connectors, we've seen literally 2 plus 1. But if I ignore that 2, that's 1%. So there's like 99% more connectors left. And let's say which ones I can directly find. Okay, there is one for Snowflake. This is cool as well, right? Snowflake is very popular. You're probably familiar with them. So if you need, I'm not surprised they have a connector for Snowflake. What else? You have Amazon S3. Let's see what this one is. Sure, I can guess what it is, but I'm going to just read it out. You can use the S3 connector for Confluent to export Avro, JSON, Protobuf, blah, 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 from topics to S3 objects. Okay, to data from, so you get a topic, you get this message, you use this connector to S3 objects. So how does that work? How do you convert? So let's say I want to pick up messages coming to podcast topic B. Let's see, is it going to ask me for this secret and access key? And again, you want to have different service accounts. Maybe it asks for the bucket name. Yep, exactly what I expected. The access ID, key, and the bucket name. Once we do that, I'm wondering whether it actually creates like ASCII text files with these messages or how it does it. Maybe if there's interest, if you want to know more about some of these connectors, let me know, and then hit me up on LinkedIn, or again a comment on the podcast, or however you want to do it, and we can certainly get into these because it looks reasonably straightforward. Because I was expecting it to ask for the key and the key ID and secret access key and the bucket name. That's exactly what it does. I'm just curious to see how it's gonna write it. Let's go back here. Because it said all of these, oops, hang on, go back. All of these formats, let's go to documentation, S3 sync. Periodically pulls data from Kafka and in turn uploads it to S3. The key name encodes a topic and the start offset was data chunk, blah, blah, blah. Yep, so it's probably going to, I don't know if it's going to create one file for each message. I don't know, or how it actually starts adding it. Oh, hang on, it's open your bucket and each subsequent until you see a message is displayed. This sounds like there's probably one file per message. That's what I would go with as an assumption till we learn otherwise, right? It's probably a file for every message that's actually coming through to your topics. Now, I don't know if there's any level of filtering that you could possibly do, saying, hey, I want only messages coming to posted to this topic with a certain header. I want this connector to pick up those specific messages and not all of them. I don't know what level of granularity it actually does support, right? We're going to have to play and learn. But if it does, great. If not, we'll have to figure ways to react to that. There's one for Elasticsearch. And now I can tell, there's going to be, if I search for SQL Server, yep, you see that there is SQL Server. This one says from Kafka topic to SQL Server. This one says of the existing data in SQL Server, connect snapshot and then monitor and record all subsequent row level changes to the data. This one is, what is the difference? SQL Server CDC source and SQL Server source. Change data capture source connector. I don't know. Maybe some SQL Server specific differences here. Change data capture. And this one is that obtains a snapshot of the existing data and then monitors and records all changes. So, I mean, you can read into it to see what the actual, I'm actually curious now. Change data capture, can obtain a snapshot of the data. That was for SQL Server, this for Postgres. And what is CDC? Allows you to capture data changes in source databases, but we still need to communicate and propagate these changes to downstream systems. Blah, blah, blah. Okay. What is DBZM? Is an open source platform for change data capture built on top of Kafka. Its primary use is to record all row level changes committed to each source database and a transaction log. Okay, I have never used this one here. Data pointed to your apps can start responding to all of the inserts, updates, and deletes. Okay, so I guess using this, you can tell the delta, right? What changed? Because remember, I think I mentioned that like 15 minutes or 10 minutes ago, as to can I only watch for certain kinds of events. So probably that's where DBZM, if I'm even pronouncing it correctly, comes into play. So it says it lets your apps react every time your data changes. And when that happens, you can use this connector to actually sync that with Kafka, essentially, right? So, I need to make a list of these that we should actually check out. I think the other day we looked at, what was that? Was it Flink? Yep, Apache Flink. And then there was the KSQL DB. I'm actually forgetting. I need to make a list of these items. 3. And then now it's DBZM, right? Okay, cool. So that's what it is. So it's SQL Server. And we saw Postgres. It's got the same combination, CDC, sync, and source. So I reckon the difference between this one and the source is this says it obtains a snapshot of the existing data and then monitors. This also obtains a snapshot, but uses the, maybe if you wanted to react to actual changes that are happening in terms of inserts, updates, and deletes, you might have to use change data capture, versus this is something that you use when you're not doing this at real time. Not exactly certain what the difference between these two are. You'll have to play with it to figure out. Okay, suspect MySQL has the same 3 combinations. So it's got the database connectors. We've seen the S3 connectors, Snowflake, and we didn't go into Elasticsearch, but let's do Elasticsearch again. One more time, you pick the topic, pick the access, pick the ACL, and now you're going to have to, key in the URI, username, and password, right? I think, having tried a couple of these connectors while you've done in the podcast, it should be very straightforward to add these connectors. And, by having these connectors, I can only see value through a managed Kafka service, because now you don't have to worry about how you're propagating your topics, messages posted to topics to different systems, and vice versa, how you're pulling data from your other systems into your messaging platform, essentially, right? So you can only see where the value add comes from. Of course, they have, let's see how many they have for Salesforce. We got quite a bit. Salesforce, bulk API, platform event, S-object, push topic. So they have about 9 connectors, I guess, for Salesforce. Let's see what they have for Oracle. They have the same combination, the CDC, the database sync and source, and they have a couple of more for Oracle products. Okay, what else? That's a bunch of database related stuff. They have a Jira source connector. What does this one do? It's going to ask me for Jira URL, username, and API key. I guess this way you can start posting to it. So in other words, if we needed, to add a new connector, I wonder how we can implement a connector and plug it into Confluent, because now I'm thinking, let's say you want to integrate this into the Snowpal APIs. You can imagine having a Snowpal connector. So your Kafka topics can be propagated to the Snowpal backend systems. When you're actually integrating Snowpal APIs or SaaS products, whether you're provisioning it in your own infrastructure by licensing the products from us, or by actually using us as a service, on AWS Marketplace or other API hubs. Now, before we look at more connectors, I want to see how to actually implement an existing connector. Add a plugin. Okay, connector, plugin details, plugin description, plugin class. So source or sync. Oh, I guess source is probably where you're pulling data from, and sync is where you're pushing it to. That's probably the two different connector types. Let's look at Confluent connector type. That's probably the difference. Source connectors for external data sources and external data destinations. That's exactly what it is. So you remember I mentioned whether I was wondering whether it was thinking a lot whether it was bi-directional. It's not. And I guess it's intentionally so by their architecture, because they have a connector type that separates the two. And now I guess you could implement a custom connector. Let's see if I go to Confluent. It's called an S3 sync connector. Wonder why it's called an S3 connector. Confluent S3 sync connector. But that's a little bit confusing, because this is just a it's just an example. Sorry. Yep. The plugins Java class to be. So here I was just thrown off by that S3 sync connector. So I guess you could go to Confluent, implement connector, Confluent connectors, connect your business faster, blah, blah, blah. How do I? Yep, connector developers. Oh, this says how you can write new connectors. So those 220 something, so those are available already, but you can add more connectors by implementing these custom connectors. We were just going to talk about existing connectors in this podcast, but I'm a little bit distracted here to see how to implement a custom connector. This probably is worthy of doing it in a podcast of its own. There's a sync and a source connector. And then going through this, okay, we look at that code. Connector example. I'm just looking for, okay, let's see, where is there a topic here? Okay, topic. Config definition. This is a source connector, so it's going to pull data from the source, whatever that source happens to be. Very simple source connect that works with standard input or a file. So this is a file connector. So what is this basically saying? Extends source connector. Actually want to go to, let's see, Kafka connect. Okay, I want to look at a slightly better example, if you will. Okay, so this is a source connector and that's a sink connector. That's going to push it to, it works with standard out or a file. So the previous one was reading from a file, right? The source connector works with standard input or a file. Let's see, there's a start, task configs, exactly once support. Try to look for the actual, okay, less verbose documentation. I guess we'll have to, as a simple example, very similar, blah, blah, blah. You need to first extend the source connector, and then you have to implement the start, add some standard lifecycle methods, start and stop. Finally, the real core of the implementation is in task configs. Did we actually, task configs? Oh, there we go. So this is the core of the implementation. What does it do? Only one input stream makes sense. Let's go to a sink connector. So the sink connector writes to a file. Okay, let's look at the documentation here. In this case, you only handle a single file, so even though you may have permitted to generate more tasks, a list is it. I don't know what the, okay. Even with multiple tasks, this method implementation is usually pretty simple. I want to actually see some better Confluent connector sample code. My first Kafka connector. Let's see what they have in this one. Okay, they have a start, stop, and then the task configs, and then whatever this particular connector is meant to do. What is the purpose of this connector? I wish that was slightly. Implement custom connector. What is this example going to do? That emits numeric data. So is this a source connector? Are they implementing? Okay, let's see what they're trying to do here. We'll start by developing a simple source connector. Yep, that emits data to a Kafka topic. So this is like one of the mock connector that we checked out. So let's see. I'm just curious to know the topic task configs. Okay, so get the maximum max tasks. You iterate through it, and then you have the task config. Hang on, the task config here. So this is just, what is it doing actually? It is, oh, it emits numeric data. Okay, cool. So if you go back here to our, yep, it goes through that counter source task ID. What is this counter source task? Current iteration. Counter connector. You can think of this class as the glue between the connector configuration and the task implementation. Okay, so what they're essentially doing here is actually, this is actually a pretty simple example to try out if you actually want to do it at a later time. So they're just going through and I'm just, where is this max tasks initialized? Is there a configuration that initializes? Before we go to add the connector, let's see. Okay, this is the Maven. Okay, this is the POM file and it has the entry for this connector that we are creating. Okay, Kafka connector, there's a description, organization, component type source versus I reckon the other one is going to be sync, connector, config. I'm just looking to see what defines the max tasks. Okay, let's go back here. Let's go back to the example that we had. Let me go to the source connector. I'm curious to know source connector task configs. Was that not called? Yep, it's overriding it. So is it not? Okay, there we go. We have some documentation here. Initialize this connector, task configs. Okay, existing task configurations. Max tasks, maximum number of configurations to generate. Let's see. It says returns a set of configurations for tasks based on the current config. Max task is the maximum number of configurations to generate. I'm just curious to know what dictates where that wiring is actually happening for the max tasks. So in this case, let's go with this example. Sometimes easier to just try it than to speculate here. Hang on. So this file was the counter connector. Here's the counter source task. Okay, my Maven package. Add the custom connector. We go through the connector, and we saw those UI pages. Um, we will just use the zip file that is generated. Uh, we will add that. We need to add that for to make it the custom connector. So we go through page, and I think that's basically what it is. So it seems like it depends on, it can get as complex as it can be depending on the type of connector you're creating. But this is how you can create the connector, right? This is how you create a custom connector to drop on Confluent Cloud. So let's say we create a Snowpal custom connector, which I reckon we will. Actually, it sounds interesting and simple enough actually, to be able to wire data coming in, both the source and a sync connector, one to pull data from your Snowpal systems, whether you're pulling it, how either the devil is in the detail. Are you pulling data from the database from Mongo, in which case you'll just use the Mongo connector? But if you're pulling it from Snowpal as a service provider through our APIs and products, there need to be other connectors. We'll see if there are some REST or graph connectors that exist. If not, you probably have to create those types of connectors, and the sync connectors to push data into those systems. This is how you create them. The only thing I'm a little unclear here is about the max tasks. Let's spend another 2 minutes to see if we can figure out, because we went here. Maximum number of configurations to generate, but where do we dictate? Okay, let's go back here. So even though you may be permitted to generate more tasks as per the max task argument, a list is returned only one entry. Say Confluent connector max tasks. Maximum number of tasks to use for this connector, tasks dot max. So where would we define? This topic includes configuration properties available for the platform. So there are config properties. So if we actually go here, where can we expect these? Is there like a config file that you would create for these? Don't see any. Okay, main. I don't know what. Okay, let's see. Sync storage transforms components. Actually, let me find connector config tasks.max. Where should this be defined? I'm back to the same place. Yep. So we've gotten close enough because these are the properties. I'm just looking for. Shouldn't there be in this example like some sort of a properties file? Stem connector config file. Deep dive into configuration. Define configuration parameters specifying the name type, importance, etc. This says host name. So will we find host name here? No. Here's an example. Config definition. Yeah, it says whether you're developing a sync or a source connector, you'll have some configuration parameters that define the location of the external system as well as blah blah blah. I don't know if this is no, this might be a different configuration. Source connectors. Oh, hang on. I think we saw something called config underscore def. Here, back here. Yeah, the config definition file config. Oh, batch dot size. We find this. I think we've kind of solved this mystery. I don't see the batch size here. File config topic. Batch size. The maximum number of records a source task can read from the file each time it is polled. Okay, so if this is a config, why would I not find that? There's a difference in these property names, so quite certain this is what feeds into the max tasks that we saw there. At least that would be my assumption. Just not sure why I'm not seeing file topic. Probably much easier if we had implemented it. Okay. Comes from the framework and specifies the maximum number of tasks to be created, blah, blah, blah. Configure self-managed connectors. Oh, there we go. Standalone example. There's a configuration files. Standalone configuration. Common configurations. The file containing this should be added as shown in the Getting Started guide. Second param is the connector properties file. Okay, connector one, and there's, I guess you can have any number of these property files. So that's where it's essentially coming from. But I wonder how this fits into the big picture when you're actually creating a custom connector. Maybe you don't specify when you're adding the connector, you don't specify this is at, perhaps this only comes into play at runtime, right? You have to provide these values through a properties file, but maybe that's not what you actually package when you in the archive that you're uploading to creating this connector. At least that would be the assumption I would go with till we learn otherwise, right? That seems to make the most sense to me at this, given what we, so essentially includes all the connector configuration properties. How you pass values for these properties? It's probably you'd pass it through a properties file at runtime, not so much that it's not a property file or a properties file that you need to include in the initial artifact that you create and upload when you're registering this custom. Hopefully I'm still recording. When you're registering this custom connector, at least that would be my takeaway, right? And I think it wouldn't be a bad first assumption to make, at least. Okay, I will go close these things. Close this one as well. Close this, close this, close this. Okay, so that's as far as a custom connector. So we didn't start wanting to know how custom connectors, I didn't even know there was a notion of custom connectors, even though it makes sense now that you think about it, that this is not a hard-coded list. So you create your own connector and then you publish it to Confluent. And I wonder what onboarding process they have, because what if your connector does not work? I presume they would do, some sanity testing, approvals, and then once it's good, it probably becomes public here, right? So I don't know what the development process is. You would probably work in a sandbox environment, connect to lower, dev, much lower environments before so you test it, get all of it working. So I don't know what that experience is going to look like in terms of how you're going to create this custom connector. But it seems like it should be a reasonably seamless process to creating these connectors and then publishing the connectors here. So we saw, of course, there's a connector for DynamoDB. Now that we've seen a bunch here, SQS, let's see if there's anything for SNS. Nope. Okay. There's Datadog connectors. Can use this to export data from Kafka to Datadog using the post time series metrics API. So I don't know what kind of, so you have a Datadog connector to export data from your topic to Datadog using the time series API. That is actually interesting. We'll have to look at that. I'm not exactly certain in what context you might actually use that. And there is a GitHub connector to write data from GitHub to Kafka. So if you're pulling data from your GitHub projects, there's an HTTP sync and source connector. Okay, what is... Okay, so this is when I would like to, I actually might want to try this one out. So if you, let's say you want to connect to, you want to pull data from a Snowpal endpoint, it looks to me like I can actually add, like a token here, right? Basic none auth to, okay, what bearer token? So you'll basically get the you'll add the bearer token for the system you're integrating, into the HTTP source connector. And essentially, after you do this setup here, the configuration, uh, let's say it's a get endpoint, right? Let's say this is a get endpoint. For example, where offset will be substituted, the offset generated from the previous request response will be substituted values, which the HTTP API URL, which can be templated with the offset and entity information. Offset will be substituted with the offset generated from the previous request response. So we'll have to play with it to see how the mapping happens here. So that's an HTTP URL, and the entity name after the version v1, for instance, is that the variable substitution. I'm trying to see how you might use Confluent. See if they have an example here. Entity names, app name, user. Yeah, polls for data from HTTP API and produces records for that source in Kafka, right? So I guess it says polls. I wonder what the frequency of that is, or how configurable that might be. Yeah, it looks like JSON SR is really the short form, I guess, of JSON schema. I've used JSON schema. I just didn't know that it's actually called JSON SR. Okay, I'm just going back to a couple of things we talked about at the beginning of this podcast. So this is the HTTP source connector to pull from an HTTP API. And then they have the HTTP sync to actually write. So you take data from a particular topic, then you pick this, go next. Okay, this one is basically going to sync. It doesn't have, so the auth type, there is one missing clearly. It's basic. None and auth 2. You don't see the bearer token in this case. Okay. HTTP, what is the sync connector? And convert each record to a consume the records and converts it to a string before sending in the request body to the configured API. And this one looks slightly different. Okay, so there are some nuances there clearly, with the HTTP connectors. What else might be of interest? So MySQL, there's New Relic connector. We've seen the database stuff in Salesforce, this ServiceNow connectors, ActiveMQ, Zendesk, some Adobe connectors, and Amazon. Let's see what else is there in the Amazon world. S3, Redshift, DynamoDB, CloudWatch, SQS. Okay, number of things we actually currently use at Snowpal. Okay, Redis connector, App Dynamics, Cockroach DB, Databricks. As we can see here, there is like a wide variety of existing connectors. Oh, there's one for Rapid API, was it? Customizable marketplace. Yep. Okay, so this, let's see, Author Rapid API, right? So these are custom connectors created by those companies. Okay. Splunk, TIBCO. Okay. I think we've gotten a sense of these connectors, right? We've learned what they are, how to create custom connectors. what the different types of connectors are, source versus sink, what each of them meant, an hour ago, uh, we had no idea. At least I had no idea. So if I came to this podcast with little like clue or no clue about connectors and connector plugins when it came to Confluent Cloud, hopefully you're leaving that with some learning, right, to actually get you started here. So this is podcast 4 in this Confluent Cloud series where we've pretty much focused on connectors. We've taken a look at some connectors. We saw some data flow through. Hopefully I paused that one so we don't get charged for that. Yep, it's paused. So you can, you pay by use. So you can add multiple connectors, check them out, pause them when you're not using them. Um, and I don't know if there's a way to actually start and stop this. I'm pretty sure through the command line, there must be some ways to doing it. We've been interacting through the user interface, but there must be a Confluent CLI as well. Pretty sure. Yep. There's this Confluent CLI. Let's see. I'm not going to install this now. But what are some commands? Confluent CLI commands or Confluent CLI command reference. Manage keys. Let's see what we have with respect to connect. Connect clusters. Okay. So there's manage Kafka. Okay, Confluent Kafka cluster, ACL client configuration. Create a client config file. Region, manage Kafka topics. Can create, produce. Okay. So you'd use, so this is the CLI essentially, right? But that's good to know. But not exactly what I was looking for. I was looking to see if we can start and stop these connectors, which pretty certain there must be something that allows you to do that here, right? So if you don't want to do it, you want to do it programmatically, or have a way to actually bring these environments up and down, then you want to, to save cost and whatnot, right? So you want to check out the CLI essentially. Saves environment configuration. So I reckon there must be something in here. With that, I think we should, we're a little, what is it like? A little over an hour. But I think this was a good one. We got deeper into the Confluent Cloud's notion of connectors. And I think I have a reasonable idea as to what they are after the 60 minutes. Then at least I did at the beginning of this. Hope you have some learnings from this as well. Thanks, and I'll talk to you later.